Hello, I am Nick, and this is a snake game we are going to make in the next 10 minutes. Our snake eats apples and counts them, moves in all 4 directions, passes through the corners, dies when eats itself, and resurrects if we want to play again. We will code it in a pure Python in 75 lines of code using just a Kinter library. And this is our starting point, a Kinter boilerplate. Nothing fancy here, it just renders small boring white window and that's it. Let's start code snake with the game class that holds all game logic and knowledge. Knowledge for now is very limited, we know nothing except the game field size. But it allows us, instead of small boring white window, render the boring white window of needed size. Our next step is to make it less boring by rendering the game space. The space variable will contain a list of all coordinates of the game field. And we will just render each cell as a non-boring square of color green. Let's make it even more funnier and color odd and even cells with different shadows of green. Now is the time to reveal the game's main protagonist. We will create a separate object to represent a snake. It will just be a list of snake body coordinates with the snake head at the end of the list. But before rendering it, let's make some refactoring. Okay, seems like everything looks the same. We didn't break anything, which is usually a good sign when you do refactoring. All we need to do now is to render a snake cell with a different color than a field cell. We can go even further and distinguish visually the snake head from the snake body. We'll represent an apple as a random coordinate within a game space set minus the space already occupied by the snake. And let's make it just red. Let's ensure that every time I run the game, apple appears in the random part of the field. Time to teach the snake some cool moves. Let's pause here and answer the philosophical question, what does it mean for a snake to move? I think it means to grow a new head and cut a tail. To do it effectively, we need to transform our snake object into a deck, a data structure that can push and pop from its both ends. And also we'll introduce a direction object to reflect the direction the snake moves. It will be just a pair of increments we need to apply to the row and columns coordinates of the snake body. In our case, that means to move right. All the wisdom I've been saying here for so long is reflected in the advance function. It is doing exactly what I said, creates a new head along the direction, appends it to the snake and chops a tail. We are almost there, I promise. All we need is something that will periodically call advance function and then update the view state. And it is the update clock function, it will call itself every time after 80 milliseconds. And as for update the view function, believe it or not, we already have it. Here it is. Okay, our snake goes right to eternity. Let's make it pass through the walls and appear at the opposite side of them. That's better. The last thing I really don't like here is two verbose calculation of new head coordinates. Let's make it the one-liner with the help of some Python magic. Now it is time to deprive the snake of its will and give full control over it to a player. So at the start it will not go anywhere and will store every player's move to the moves deck. Let's decide that the player move is a pair of coordinates representing a new direction. In the advanced function, we will just shift the new direction from the moves deck. Of course, we don't need to create a new head if it's inside the snake. We don't want to eat ourselves, it is usually a not good thing to do. Okay, so let's set it on up move by binding it on the up arrow key. Let's give a player a full set of moves now. they pass through the middle of the video and it's time to actually start to eat these damn apples. It's quite simple thing to do, we just don't need to cut the tail if we ate an apple, we need to respawn a new apple instead. We will extract the respawn logic to the separate function. But there is a small bug here related to our moves logic. If a player chooses the direction as opposed to the current one, the snake will stuck, because it will try to raise a new head inside her neck, which we deprecate. It will reject moves that are strictly opposed snake's current direction. Time for calories counting. This logic is self-explanatory. The only thing what needs to mention here is what we will create a new widget, a status bar to show how many apples we ate. And we'll display that at the very end of the update the view function. And thanks to the emoji, I don't need to steal an apple icon from the internet. We have almost done it. The last thing we need to do is a game over logic. When the game is over for our snake, then it tries to eat something below its head, I'd say. And what we should do when the game is over? Well, we should not react to move commands and to tell the player the game is over. The very nice thing we can do additionally is to restart the game in case of game over, when the player will try to press some move command. Congratulations, I'm so glad that you're still with me. Before we measure how many lines of code our snake occupies, we need to look closely at this line. Remember it? It is good if you don't, because it's a completely useless line, let's kill it. And now we can scientifically measure how many lines of code we wrote with the help of the CLOC tool. 75, I didn't lie to you. If you appreciate it, please click like and subscribe to the channel.